Okay, ladies and gentlemen, welcome to the video for the first 3 examples of algebraic proofs. Again, there's going to be a total of 5 examples recorded and that we will go through together as a class to prepare you to complete the remainder of the algebraic proofs packet. We are going to do numbers 1, 3, and 4 in this video from the algebraic proofs packet. So these will be examples of algebraic proof if you're someone who's not in my course. This is how you do a formal geometric proof of solving a linear equation. So, anytime we're asked to prove a statement that is an if-then form, the hypothesis of that statement is your given. So the hypothesis of that statement would be the equation 2x plus 7 equals 15. So that's what we are given. And the conclusion of your if-then statement is what you're being asked to prove. In this case, you're being asked to prove that x equals 4. Every proof starts exactly the same way, by stating the given information. So the first statement should once again be us stating that 2x plus 7 is equal to 15. Now if we're solving this in an algebra class, we would start by subtracting 7 from each side of the equation. In a formal proof, we would need to show that step. So we would write it out as 2x plus 7 minus 7 equals 15 minus 7. So we're going to show that subtraction in the first step. Now once we show that subtraction, we are then going to simplify that. On the left side, the 7's will cancel, leaving 2x. On the right side, 15 minus 7 is 8. This is one application of the substitution property. And in my class, I have my students write substitution with the word simplify in parentheses afterwards, because that is what we're using the substitution property to do, is to simplify the equation. Now in an algebra class, our next step would then be to divide each side of 2x equals 8 by 2, which is what they're showing in step 4. This is an example of our division property of equality, which says that I'm allowed to divide both sides of any equation by any real number except for 0, because we're not allowed to divide by 0. First we show that step, which is us showing division there in step 4. And then we use the substitution property to simplify that equation down to x equals 4. Notice that the final statement in your proof matches what you were asked to prove, that x equals 4. So on to the next example. This one is already written in given, no it's not, I lied. It is also an if-then form. So once again, your given is going to be the information that is the hypothesis of your statement. That is 9/2 times the quantity x plus 3 is equal to 27. We assume that the hypothesis is true, meaning that that is a true statement. We are asked to prove that x equals 3. I don't know why this popped out. Let's get that out of the way. Okay. So we start off with our given information, which once again we're stating the equation, which says that 9/2 times the quantity x plus 3 equals 27. Now one downside of the fill-in-the-blank proof is that you have got to follow my thinking process. This is not the only way to solve this equation, so it is not the only correct algebraic proof. This is only one possible answer. So one way that we can deal with a linear equation that has a fraction in it is to clear that fraction. And we clear that fraction by multiplying both sides of the equation, every term, by what would be the common denominator of every fraction in the problem. In this case, there's only one fraction in the problem, 9/2, and the denominator of that fraction is 2. So you'll notice in step 2 that we are multiplying both sides, every term, by 2. 2 times 9/2, 2 times 27. We are not going to multiply the stuff inside the parentheses, because 9/2 times quantity x plus 3, that is all one term. So by multiplying the outside by 2, I'm actually multiplying everything by 2. That step is multiplication property, because I am multiplying both sides of the equation by 2. First we show that, then in the next step we simplify it. That is a substitution simplify. And you may have picked up on this already, but anytime that we add, subtract, multiply, divide, or distribute, we show it, like we did in step 2, and then we actually do it, we simplify it. 2 times 9/2 is 9, 2 times 27 is 54. Our next step says we're going to use the distributive property. So once again, in a formal proof, we're going to have to show that. So when we distribute, we do 9 times x and 9 times 3. So our step 4 should show that distribution, 9 times x, 9 times 3. After we show it, our next step, we actually do it using our substitution simplify rule. So that would become 9x plus 27 equals 54. Algebraically, the next step in solving this would be to subtract 27 from each side. Notice they have shown that in step 6. It is the same as step 5, except they are subtracting 27 from each side. That is the subtraction property of addition, which says I'm allowed to subtract whatever I want from both sides of an equation, as long as I keep the equation balanced. In step 6, we're showing that subtraction. That is then, just like all the other times, followed up by us actually doing the subtraction using the substitution property to simplify the equation. 27's on the left side cancel, leaving 9x. 54 minus 27 is 27. Algebraically, the next step in the process would be to divide each side of the equation by 9. So in step 8, we are supposed to show that, dividing each side by 9. That step is labeled division property. And then after we show it, we finish it off by using the substitution property to simplify it down to our final answer, which should be x equals 3, and is. One more example in this video, then we'll stop this one and have one more video afterwards. This one is already in given proof mode, so we should be able to start a little bit quicker. We start off by writing the given information, 30 equals 16 plus 1/5 x. Now this time I chose not to clear the fraction. Instead I started off by subtracting 16 from each side. So step 2 is the subtraction property, because I am removing 16 from each side of the equation in an attempt to get the x by itself. 30 minus 16 simplifies to 14, and on the right side the 16's cancel, leaving 1/5 x. This means for step 3 I am using a simplify step. I'm using substitution to simplify. The next step then would be to get rid of the 1/5. We get rid of the 1/5 by multiplying each side of the equation by 5. So we do 5 times 14, 5 times 1/5 x. Again, we show that in step 4, which is labeled multiplication property, and then we simplify that using the substitution property. Now the reason I'm writing simplify instead of substitution property is that we're actually using substitution differently than we will later in the book when we do geometric proofs. So I want to make sure that you understand there's a difference between using substitution property to simplify and using substitution property as it is actually intended. Now the reason we're not done after step 5 is that 70 equals x is not geometrically exactly the same as x equals 70. We have to flip that equation around. Fortunately, we have the symmetric property, which says if A equals B, then B equals A, that allows us to easily switch those sides. That would complete this proof and this video. Thank you for your time. There will be an additional video showing examples 8 and 10.